Welcome to SciGenie Institute. In our today's tutorial, we're going to go over test 1 preparations for physics 101. As you can see, this is the coverage for your test 1, which you're going to have tomorrow. Okay, so for you to prepare well, I've prepared you many exam questions which may run up to 50 questions, which we are going to go through together so that it may be easy for you tomorrow when you be writing your exams. Okay, take note that you need to answer all the questions. So since you don't have enough time, make sure you take screenshots of the questions which I'm going to be solving so that you revise after watching the video, because I'm going to do questions from test 1 which you learned from 2024 all the way to 2020 to 2023, also exam questions. Okay, exam questions from the same year 2024 to 2020 to 2023. So I've got a number of questions. So as you can see, this is your coverage. We have standards of length and mass and time, dimension analysis, uncertainty in measurements, significant figures, conversion of units, estimates and order of magnitude, vector analysis, motion in 1D, motion in 2D, which is also called projectile motion. So I've prepared for you a number of questions which we are going to tackle together. One thing which I want you to know is that I'm going to be letting you know of the in the description section. I've shared a number of links to the questions which you need to go through also. Okay, so just to follow the instructions, then you're going to make it well with your test 1. Alright, so we are going to start with the 2024 test 1. Okay, so the first question is, what is an approximate value for the speed of sound in air? Okay, so this is coming from estimation. Alright, so the speed of sound in air at room temperature at 20 degrees Celsius is approximately 343 meters per second. So as you can see, this 343 is close to this one. Okay, it is close to this one. So the answer goes to be B. So now let's do question 2. A projectile is fired in such a way that its horizontal range is equal to 3 times its maximum height. What is the angle of projection? Okay, let's do it again. So the first thing, let's read the question again. A projectile is fired in such a way its horizontal range is equal to 3 times its maximum height. So that means to say the height is smaller than the horizontal is seems to be longer than the what? So once this is fired, a projectile is fired like this, you're going to find that the range is equal to 3 times the maximum what? The maximum height. That is what it means. So from this we can write an expression which is going to be like R is equal to 3h. What does this mean? It means that the range is equal to 3 times the maximum height. That means 3 times the maximum height. Alright, so what we can do next now is to understand that this is projected at a certain angle, and an angle of projection is what we've been asked to. Alright, so as you can see, this is case 2. This is case 2. Alright, so to understand all cases on projectile motion, you need also to check for the link in the description section. I'm going to share the link for all the cases on projectile motion so that you understand how we derive the formulas and the formula which are used and when to use them. Alright, so what we need to find the angle. We also, so to find the angle, we need to understand that the range here in case 2, the range is given by v initial squared, then sine 2 theta, okay, over acceleration due to gravity. Then the height, okay, the height is given by v initial squared, then sine squared theta over 2 times acceleration due to gravity. So what we are going to do here, we are going now to replace in the formula, because we already have to say that r is equal to 3h. That means why there is r, we replace this. So we're going to have v initial squared, then sine 2 theta over g is equal to 3 multiplied by height. We have this, which is v initial squared sine squared theta over 2g. Okay, now what I want you to see, to say that v initial squared is common everywhere. Okay, so v initial is going to cancel because it is common everywhere. Even g is common everywhere. Okay, so what we've remained with sine 2 theta is equal to sine squared theta over 2. Okay, sine squared theta over 2. So here we can cross multiply. We are going to have this times this. We're going to have 2 sine 2 theta is equal to sine squared theta. Now, when you start doing trigonometry, you are going to understand to say that sine 2 theta, okay, sine 2 theta, once you start doing trigonometry, you're going to understand the double angle identity, which is sine 2 theta is equal to 2 sine theta cosine theta. For now, don't panic. Just I can encourage you to memorize this, because I'll teach you very well in mathematics when we start doing trigonometry. Okay, so what you do here, so since sine 2 theta, this is going to be replaced while there is sine 2 theta. So that means 2 and 2 are going to multiply, are going to have 4. Then this will be replaced by this. Okay, we're going to have sine theta cosine theta is equal to sine squared theta. Now, you need to understand another thing which you can understand is that another thing, actually I've forgotten this 3. We must have 3 here. Okay, even here we must have 3. That means to say, since we have sine squared theta, this is same as this sine and sine squared is going to cancel. That means this is same as x, then we have here x squared. That means if we divide x into x squared, we're going to remain with x. So same applies. So sine squared is going to cancel. We're going to have 4 cosine theta is equal to 3. Now sine squared, it means we have 2 sine ratios. So that means we're going to remain with it sine theta. Here, what I want you to understand is that we can divide by cos everywhere. Okay, divide by cos, we also divide by cos. Okay, so we are going to this, and this will cancel. We're going to remain with 4 is equal to 3. Now, a trig ratio, sine theta over cosine theta is tan. Okay, you need to understand that. We're going to have tan theta. All that you're going to understand when you start doing trigonometry. As for now, you shouldn't worry. Just understand to say that sine theta over cosine theta is equal to tan theta. Okay. So we have 4 is equal to 3 tan theta. So we can divide the 3 everywhere. We're going to have 4 over 3 is equal to tan theta. To get rid of the tangent there, we're going to say theta is equal to inverse tangent of 4 over 3, of which we're going to have 53 degrees. So the answer goes to be 3. Here we don't need to memorize answers, guys. Know how to solve, because sometimes lecturers are very intelligent. What they can do, they can bring this question to structured question where there are no option to section B, where you need to answer. So if you memorize the answer, what if it is asked to section B? You're going to suffer a lot. Okay, so let's go ahead and do the next question. Okay, so the question reads: a pendulum bob is held stationary by a horizontal force H. Okay, the 3 forces acting on the bob are shown in the diagram. As you can see, we have the tension force T, we have the weight force W, then the string is held at an angle of 30 degrees. We can see that our 30 degrees is here to the vertical. Which statement is correct? Okay, so the statement which is correct is here. So what we are going to do is very simple. Okay, what we are going to do is very simple. As we can see, we have an angle here. We have an angle here. Okay, we have an angle here. This is an angle which we have, and we have our weight force. Our weight force is here, and we have 8 and our tension here. Okay, so the first thing which you need to understand is that we need at least 2 forces which are going to be in both direction. If, for example, the other one will be going this side and the other one will be going this side, so that we equate. Okay, or we have the other one which is going up and the other one which is going down. If we can achieve those 2 forces, then it will be right for us to equate and find the force. So as you can see now, looking at this, we have the tension force. The tension force, as you can see, this can be broken down in 2 components, okay, because it is at an angle. Okay, so since this is at an angle, it can be broken down into components. Here we have, and we have this. Now what I want you to understand is that, as you can see, we have our 30 degrees here. Okay, from grade 8 you learned about alternate angles. If angles are in any, the angle here and the angle here are the same. That means if we have 30 here, it means even here at this angle we also have 30. Okay, so we have 30 here. We have 30 degrees here. Okay, so now when you look at this, I can bring this triangle now down. I'll write it here. I'll write it now so that you can get the concept clearly. Okay, so we have our 30 degrees here, and our T is the hypotenuse in this case. Okay, so what we are going to do is simple. We are going to have our T1, also our T2 here. Okay, so now in this case, our T1 is lying at our T1 is lying opposite to this angle. As we can see, this is opposite to this angle. Okay, so our T1 becomes to be this, and our T2 becomes to be this. Okay, now as you can see, since we have this T2 which is in the same line with the weight force, this is achieved. Now we have T2, we also have the weight force. Okay, so this question actually is coming from projectile motion with some concept of forces. So actually not projectile motion, but from vectors, also the concept of forces. So what we are going to do here is this. So now what is T2? So now T2, as you can see, it is lying adjacent to the angle. So since it is lying adjacent to the angle, we are going to say that T2 is same as the x component. So T2 is going to be t cos 30. Okay, t cos 30. Then now looking at these these forces which are acting, we are going to find to say that since T2 is going up, it's going to be positive. Okay, now in this case, let me just say it is T, since in the question we don't have a T2, so we are going to treat this to be T. In this case, it is going up, then the one which is going down, because when the force is going down, it becomes negative. Okay, now what you need to understand when you start doing forces, you're going to understand to say that this system is not moving, okay, because you've been told to say that we assume to say that this the two forces were balanced. Okay, when the two forces are balanced, it means the net force is equal to 0. Okay, if the net force is equal to 0, that means to say that this T can go to W, can go to the other side, it's going to be positive, so we're going to have T is equal to W. Okay, but what is our T? Our T is equal to T cos 30 is equal to W. So which of the options is equivalent to this? Actually, it is option D. Okay, so now let's do question 5. Okay. An aircraft initially stationed on a runway takes off with a speed of 85 km/h in a distance of no more than 1.2 km. What is the minimum constant acceleration necessary for the aircraft? Okay, so what you need to understand is that let me read the question again. An aircraft initially stationary. Okay, it is initially stationary. Initially stationary at an angle. It is initially stationary at an angle. What is the minimum constant acceleration necessary for the aircraft? Okay, so as usual, what we are going to do is this. When they say that it take off at this point, okay, it was initially at rest. That means the V initial is equal to 0. Okay, and it took off at this speed. So this is going to be our V final, 85 km/h, which we can convert to meters per second by doing this. By now, and guys, you understand, you say 85 kilometers. So to convert kilometer to hour to meters, you multiply by 1000. Then to convert hours to second, we divide by 3600, because 1 hour is made of 3600 seconds. So you are going to have the speed of 23.61 meters per second, like this. Okay, then you have been told to say that the distance is no more than, okay, the distance here is 1.20 kilometer, which we can also convert to meters by multiplying by 1000, and we are going to have 1200 meters. Okay, so now what is the question? The question is to find the minimum acceleration necessary for the aircraft. So using these formulas, we have these formulas which I ever emphasized on knowing. Okay, I ever emphasized on knowing these formulas. So we have this one. Okay, we also have this one, V initial plus half at squared. We have many formulas which we actually need to know. Okay, so now looking at the formulas, you can tell to say that we have V initial, we have V final, we also have the speed. So the formula which is going to help us to find the minimum acceleration, since we don't have time, because in this we have time, even here we have time, so these are not going to work, so we're going to go for this. Okay, so what we do, we say V initial squared, V final squared is equal to V initial squared plus 2as. So we actually know that this is 0 because our V initial is 0. So we remain with V final squared is equal to 2as, dividing by 2s over 2s. Okay, so our answer goes as our V final, let me say, actually we are looking for acceleration, so our acceleration becomes 2, because this and this will cancel, so acceleration goes to be V final squared over 2 times distance covered there. Okay, so our V final, actually our V final is this, so we got 23.61 meters per second over 2, then multiplied by the distance, which is 1,200 meters. So we get our acceleration to be 0.23 meters per second. So our acceleration, actually after rounding it off, we get to this answer. So our actual answer is this one. Alright, so let's now understand this question. A board is released from rest and falls vertically in air of constant density. Okay, it is released from rest, then it falls vertically with air of constant density. Which statement of the motion of the falling object is correct? As it accelerates, that is A, its weight decreases so that its acceleration decreases until it travels with constant velocity. It accelerates initially at 9.8 meters per second, but the drag force increases so that its acceleration decreases. Its velocity increases at constant rate until its velocity becomes constant. The drag force of the hair increases continually, and eventually the velocity decreases. So the concept here is very simple. So this board is released. Let's say this board is released. So when the board is released, okay, it experiences two main forces. Okay, it experiences two main forces. So but any object which is falling, any falling object experiences the what? The weight force. The weight force is the first thing which it experiences. Okay, another thing which it experiences is the drag force. The drag force, the weight force acts downwards. It brings something down. That's why when you jump, you come back. Okay, there is a force which brings you down. Okay, so it is, and this force is a weight force. Now there are some forces. Let's say, for example, you throw something up, something like something which is very wet, like a paper. Try to throw up a plastic. You see that as it will be coming down, sometimes a balloon, let's say for example, a balloon may even go up. Why is the balloon going up instead of coming down? Because there is a force which is taking it up. Okay, and this force is what we call the drag force, which is commonly called air resistance. So the air is going to resist the motion. It is going to pull it back. It's going to pull it up. Okay, so it's like these things are fighting over each other. So what you are going to do is this. When this object is falling, it is released. Initially, as it is released, the weight force on top here you know that the weight force is given by mass times gravitation. Okay, you know this is mg. So on top, this gravitational force on top, as it is released, it is fully 9.8 meters. So it is going to accelerate at 9.8 meter per second square. This is what is going to happen. Okay, now as it will be dropping, the drag force will start now fighting this acceleration. It will start taking the object up. Okay, it will start taking the object up. So what is going to happen is that this is going to be reduced, meaning the acceleration due to gravity is going to be what? To be reduced. Okay, so at least it is at this point, and it is being brought down by the weight force. Now as it goes up, it is being what? As it is going down, the drag force acts on it, reducing the acceleration. So what is going to happen is option B. So it accelerates initially at this point, but the drag force is going to increase and going to reduce. The acceleration is going to decrease. Okay, so in an experiment to determine the acceleration of free fall G, the period of oscillation T and length L of a simple pendulum were measured. The uncertainty measurement of length is estimated to be 4%, and the uncertainty in measurement of T is estimated to be 1%. The value of D is determined using this formula. Okay, what is the uncertainty in the calculated value of D? So the uncertainty in value is going to be given by the relative uncertainty in L here, because this depends on L and T. So we're going to in L plus the relative uncertainty in T. Now to find the relative uncertainty in L, we understand L is only raised to the power 1. Okay, so since L is only raised to the power 1 and the relative uncertainty in L is 4, we're going to say 1 times 4%. So we have 1 times 4% plus the relative uncertainty in T. T is raised to the power 2. So it will be 2 times the relative uncertainty, which is actually 1%. So the relative uncertainty in D goes to be 4% plus 2%, which is actually 60%, and the answer is actually D. Okay, so let's go and do question 8. So an astronaut on a straight planet finds that she can jump a maximum horizontal distance of 15 meters if our initial speed is, what is the free fall acceleration on the planet? Okay, so what we need to understand is this. Okay, the astronaut on a strange planet find that she can jump a maximum horizontal distance of so the maximum horizontal distance in this case is the range, because the range is the horizontal distance is 15.0 meters. Okay, and the initial speed is given to be 3 meters per second. What is the free fall acceleration on the planet? Okay, so now understanding the case. Okay, understanding the case, let's say the planet is actually Earth. Okay, so if this is the land, okay, and this astronaut is expected to jump, okay, the range, which is actually to be 15.0 meters. Okay, now they said to say that it can jump a maximum horizontal distance. So now the maximum horizontal distance, so let's say we have an angle which we don't know. Now the maximum horizontal distance is achieved at at when a projectile is launched at 45 degrees Celsius. This is what you need to understand. The horizontal distance is achieved when the projectile is launched at 45 degrees Celsius. So the question is, find the free fall acceleration. So since we have this information, we can use the formula for the range using case 2, because this is case 2. Actually, watch for the video on cases like I said. So the range for case 2 is given by V initial squared, then V initial squared sine 2 theta over R. Okay, this is what you need to understand. So now, what are you going to do next? What are you going to do? This is not Allah actually, my apologies. So this needs to be G. Okay, this needs to be G. So we get to have our R, we have 15, our V initial, we have 3 squared, then sine 2 times 45, because theta is 45, then G. So solving for this, like we said, this times this, we get 15G is equal to 3 squared, then sine 2 theta, 2 times 45. So to get rid of 15, we get 15 here over 15 here. So do 3 squared sine 245 over 15, but this will cancel. So our gravitational force is going to go as approximately 0.6 meter per second square after rounding it off. Alright, so next let's do okay. So now next let's do this. In still air, a bird can fly at a speed of 10 meters per second. Okay, the wind is blowing from the east at 8 meters per second. In which direction must the bird fly in order to travel to a destination that is in order for it to travel to a destination that is due north of the bird's current location. Okay, so the simple way to understand this, because this question is seeming to be coming from relative velocity. So what you need to understand is that the speed of the bird, which is VB, to mean B the speed of the bird, so it's 10 meters per second. Okay, then the wind, the speed of wind is actually 8 meters per second. Okay, so what you need to understand is that this wind is blowing from east. Okay, is blowing from east, so it is blowing from east, so it's moving from this east direction, it is blowing in this direction. Okay, so what you need to understand now is that we are going to say, if the wind is moving in this direction, the wind is moving in the direction, so we are going to have an angle here. So we need to connect the two. I want you to show you something. Okay, so here we can have an angle. Okay, we can have an angle for the what? For the bed. Okay, we can have an angle for the bed. If this is the speed of the bed and this is the speed of the wind, and we have an angle here. We have an angle here. So to solve this angle, actually the what should go like this. We must have something which must look like this. Let's say we have let me draw something which must not be confusing. So we have the VB here. Okay, then the angle, let's the angle here. Our aim is to make this to be opposite to the angle. So using sine theta is equal to opposite over adjacent. Opposite over adjacent. Opposite over hypotenuse, I mean. So in this case, our sine theta is going to be our opposite in this case. As we can see, it's VW, which is actually 8. And our hypotenuse is VB, which is actually 10. Okay, so to solve for theta, you say sine inverse over 8 over 10, which is going to give us 53 degrees. Now, what about the direction? The direction, as you can see, let's say this bed was the bed was moving in the north, okay, and we know that this was in the east direction. Then the bed here, okay, so that means to say the direction would be now west. Okay, the direction is going to be east of north. Okay, east over north. So the answer goes to be this one. Question 10. Physical quantities can be classified as vectors of scalars. Which pair of quantities are both vectors? So as you can see, because velocity is a vector and magnetic field strength is a vector. Alright, so we can come now to this question. Okay, so the force F between 2 point charges Q1 and Q2, a distance r apart, is given by this formula. We're going to understand this formula very well in semester 2, where k is a constant. What are the base units of k? So this is you are going to find the units of k using dimensional analysis. So as usual, I've been given the formula to be this one: Q1 Q2 over r squared. The first thing is to make k, which have been asked, the subject of the formula. So I'm going to have k Q1 Q2. Because we've already crossed multiply here, we're going to have f r squared. That means we're going to divide everywhere. We're going to have k is equal to f r squared over, now because we've divided q1 and q2. Okay, so force, to understand the units of force, we know force is equal to mass times acceleration. So the units of force are going to be mass times acceleration. Mass, because force is mass, times acceleration. The units of mass is kg. Acceleration is given by meter per second square. So to understand more, I'm going also to share the video on dimension analysis. Check for the video in the comment section. For most of you, you've watched that video. So if it's for the first time, watch the video. For you who have watched it already, don't worry. Only if you've forgotten and you want to revise more. Okay, so where there is force, we are going to replace this out. Now, what I like to do is kg times meter. Since this is over, we have this slash, we're going to say over s squared. Then we multiply by r. R is, radius is measured in meters, so because we have r squared, we're going to have meter squared. We have q here. Q means charge. Okay, Q means charge. Now, what you need to understand about charge: a charge is measured in coulombs. Okay, a charge is measured in coulombs, and a coulomb is approximately a coulomb is same as amps times second. Okay, amps times second. So where there is charge, you are going to replace this. Now, because we have two charges, is same as we are going to have a squared, then s squared, because we have two charges, s, q1 and q2, with same units, as then as. So multiplying these two, we get to have a squared, then s squared. So we are going to divide because they were dividing here. We are dividing, so we divide. We have a squared, then s squared. Okay, so now what we have, the units of k goes to be kg. Meter times meter, we have meter to the power 3, then over a squared, s, then we have s to the power 4. So now, as usual, we have kg, meter to the power 3. These are going to go on top. That means they are going to gain a negative s, becomes s to the power negative 4, and a becomes a to the power negative 2. So you can look for the one which is matching the two. Actually is this answer is B. Okay, it's B. Yes, it's B. Okay, so now the other question is, a particle travels in a straight line with speed v. The particle slows down and it changes direction. The new speed of the particle is this one. The new velocity as a component, so the new speed is this one, and the new velocity as a component, meaning this speed as a component of this in the same direction as the initial path of the particle, through which angle as the particle turned. Okay, this question is very interesting also. So what you are going to do is this. As usual, what you need to understand is that the new speed, let's say the new speed here is v over 2. Okay, and the component of the new speed, what you need to understand that this particle is traveling in the x direction. Okay, is traveling in the x direction. So the component of this, its component, we say the component of this is going to be because when it is in the x direction, the x component b is going to be this cosine theta. Okay, you understand that from vectors. So now what you are going to do is very simple. What you are going to do is very simple. The first first speed is actually given by v. Okay, so what you are going to do is this. Okay, so we are going to say the component, this component here, this, which are saying the component of v is this, is it? V over 4. So it means that where there is this, you're going to say we are going to equate to v over 4. Okay, because we have been told to say that the component of the velocity is v over 4, and the component is given by this. So we're going to use this part. We have v cosine theta is equal to v over 4. But I want you to see that the new speed is v over 2. So while there is this, we replace v over 2 cosine theta is equal to v over 4. Okay, so as you can see, v and v are common. So, or for me not to confuse you, let me just say 4 times this, we are going to have 4v cosine theta. Then 2 times this, we are going to have 2v. Okay, from now you are going to understand to say that v and v are going to cancel. That's why I was saying they are common. Then 2 into this, we are going to have 2 into 2, we are going to have 1, and 2 into 4, we are going to have 2 cosine theta. Okay, 2 cosine theta. where we can take this to the other side. We're going to have cosine theta is equal to 1 over 2, where the theta is going to be cosine inverse over half, which is our theta is going to be 60 degrees. Alright, so now the other question is the mass of a rocket propelled track is approximately equal to the mass of the fuel in its track. I want you to see this. Okay, let me read the question. Oh, the fuel is ignited and the track is propelled along the horizontal track by a constant force. The effect of air resistance is negligible. During a test run, the fuel is consumed at a constant rate. Which statement describes the acceleration of the track during the test run? Okay, so what is happening here? The mass of this rocket is approximately to the is approximately equal to the mass of the fuel, okay, in its tank. So it means that I can say that in this case the fuel is going to be represented by mass. Okay, so now the fuel is ignited and the track is propelled along the horizontal track by a constant force. So the force is said to be constant. Okay, the effect of air resistance is negligible. During a test run, the fuel is consumed at a constant rate. Which statement describes the acceleration of the track during the test run? Okay, so what we are going to do here, this connects the Newton's second law of motion, which says F is equal to mass times acceleration. So now, since the mass is actually representing the fuel, what you are going to understand is that you are going to, since they are talking about the acceleration, what is going to happen to the acceleration? We can make acceleration the subject of the formula. Okay, now for you to understand it clearly, let me replace the mass by a fuel. Let's say fuel. Okay, so now actually what is going to happen is this: increasing when fuel is consumed. Okay, as fuel is consumed, what is going to happen is that, because for acceleration to increase, we need to have fuel to be consumed, because we need to have, in the denominator we need to have less, and on top we need to have main. Yeah, so the radial force, let me just say large. So if the force, for example, becomes to be 20 and the fuel is 10, we are going to have the acceleration of 2. Now let's say for example the fuel is used and we only remained with 2, okay, with 2 kg, so we are going to remain with 10. So as you can see now, the acceleration has increased because the fuel has been consumed from 10 to 2. So what is going to happen is that as fuel is consumed, the acceleration is going to increase. So this is going to be the answer. So now we can do question 4. Okay, in order that a train can stop safely, it will always pass a signal showing a yellow light, okay, before it reaches a signal showing a red light. Drivers apply the brake at the yellow light, and this results in a uniform deceleration to stop. Let me use also stop exactly at red light. The distance between the leads and the right is x. What must be the minimum distance between the light if the train speed is increased by 20% without changing the deceleration of the train? Okay, so what you need to understand here, you need to understand to say that the question is, first of all, I've been told that what must be the minimum distance between the light if the train speed is increased by 20%. So if the train has to be increased by 20%, it means, let's say the V initial was 100% by percentage, because we don't know exactly the V initial. Okay, so now what is going to be the V final? The V final is going to be increased. So this 100% now is going to be increased by 20%. Okay, it's going to be increased by 20%. This is how we should say that the V final, the V initial has been increased by 20% because we have 100% of it and 20 more percent has been added to it because it has increased by 20%. Okay, so 100% plus 20% is 120%. And 120% is same as 120 over 100, which is going to be 1.2. So we're going to have our V final to be 1.2 V initial there. The next thing now is to understand that what you need to understand that is this. Okay, this applied, drivers apply the brake at the yellow, and this results to the uniform deceleration. So because we have the deceleration, so first of all we are going to assume that this driver started at least. Okay, the V initial going to be 0. We assume it started at least. Okay, it started at least. Okay, and what else can we understand? The acceleration is going to be negative. Why? Because it was decelerating. So from this information now, we can find this distance x, which was between the red lights, which was between the yellow light and the red light there. Okay, so we can say our V final squared, then our V initial squared, plus, now because this is negative, we're going to have minus 2ax. Since V initial is equal to 0, we're going to have V initial squared is equal to 0. We ignore this, minus 2ax. Now in this case, I just take this to be 0, to be positive. Okay, we're going to use negative on the other scenario, the next part. So to solve for x, we say 2a over 2a here. So our x remains to be v squared over 2a. Okay, so now what are we going to do next? Actually, the one which is 0 is this. In fact, we have a negative here. Just made a mistake. The one which is going to be 0 is the V final. The V final is the one which is going to be 0 because it is stopped exactly at the red light. When it is stopped, it means the V final is going to be 0. So not the initial. So the V final is the one which is going to be 0. Okay, so the V initial remains in the formula. So we keep this formula, going to use it. So now, what I want you to understand next, we are going to use this formula. We already have this expression. Okay, we already have this expression. So what we are going to do, we are going to say our V final is going out. We say where there is V initial, we are going to replace it by because we already know to say this is equal to this part. Okay, this is already to be, actually this is not x, this is don't know what I was thinking here, because here we need to have the V initial. We need to have the V initial. You're solving for the V initial. Okay, so since we have the V initial, it's going to be replaced by this. In fact, let me try to go over the question again. Think I've done some. Okay, so what we need to understand is that the V final is 0 because it is stopped. Okay, because it is stopped at the red light. So using this formula, now minus 2ax. Okay, we are going to get to solve for, we're going to say this is going to be 0. This is going to be 0. Say 0 is equal to V initial minus 2ax. So we are going to solve for this. Okay, we need to solve for we need to solve for V initial. Okay, we need to solve for V initial. So what is going to happen is that we are going to take this to the other side. We are going to have our final answer is going to be, we take this to the other side, we're going to have V initial, because when this go to the other side, it will remain, it's going to be positive, so we're going to have 2ax. Now solving for x, we're going to have x is equal to V initial over 2a, because we divide both sides by 2a, then even here 2a, then meaning this is going to cancel, and here we're going to have 2a. That this is what we've arrived at. Okay, so now what I want you to understand is this. Okay, what I want you to understand is this. We have, since after it is increased, okay, after the distance has been increased, okay, let me say that after the distance has been increased, let me say the speed has been increased by 20%, where we have this formula. We need to understand what was before. Okay, what is going to be the new thing. Okay, here is the simple trick. Okay, here is the simple trick about this. We are going to say our V squared is equal to V initial plus 2ax. Okay, I'm going to say 2ax. So now, as it was increased, we're going to have our x, making x the subject of the formula. We're going to have something like because this is going to be the V initial in this case. Now this is where we're going to rate our V initial to be 0. Okay, we're going to have our V initial to be 0, because this is our V final. Because we are going to assume to say that in the first place, because I haven't been taught, in the first place, we're going to say that it started, because the question started that in order that a train can stop safely. We haven't been taught anything, so we assume the V initial was 0. Okay, here we have V initial final, because it is clear to say that the car stopped. Okay, the train stopped. So here, by saying V initial is 0, meaning here we can cancel, and to solve for x, we can divide by 2a over 2a. Okay, so our x is going to be V final squared over 2a. Now, what we need to see is this. After having this formula, after having this formula, we can replace, because V final is equal to 1.2 V initial. So where there is V final, we're going to say 1.2 V initial. Because we have a square here, we say square over 2A. And this is going to give us something like, because 1.2 times 1.2 squared, we get to have 1.44. Then V initial squared, I've got V initial squared over 2A. Now, I want you to see that 1.44, this is same as what? This is same as this. That means why there is this expression, we're going to replace x. So, and our answer comes to be C. You have consumed a number of minutes, so try to be faster. In still air, actually this question, I think we did the question. This is same as with the one which is in test 1, question 8 also. I think question 8. We did the question. I think it's not, if not question 8, should be question 9. We did the, this is the question we did in the first press. We've done that question, so we can do to the other question. Question 10, we say that a stone is projected vertically upward from the ground at an initial speed of 15 meters per second. Air resistance is negligible. What is the maximum height reached by the stone? Okay, what is the maximum height reached by the stone? Okay, so when this is projected vertically upward from the ground at an initial speed of this, what is the maximum height reached by the ground? Okay, so we've been asked to find the H max. And what we need to know that at the maximum height on top, at the maximum height, V final is equal to 0. So we're going to use this information to find the height. Okay, and the formula, since we don't have time, we're going to say we're going to use this formula. V squared is equal to V initial squared plus 2GH. Now in this case, since it was projected upwards, that means to say the acceleration is going to be negative 9.8. Acceleration due to gravity, because this is, the stone is going to be under the influence of gravity. So we're going to have our V final is going to be 0, our V initial is 15 squared minus, because of this negative 2, 9.88. Taking this to the other side, you're going to have 15 squared is equal to 9.8. That means to remain with 8, we need to divide 15. This divide into this. 2 times 9.8, and you are going to have 11 meters. Okay, so the other question is, in an experiment to determine the acceleration of free fall using a free body, what would reach to a value that is too right? Okay, so in an experiment to determine the acceleration of free fall using a free body, what would reach to the value that is too right? Actually, the value they are talking about is the value of G. Okay, so for you to understand this, what you need to understand that we are going to use this formula. Let's use the formula. Let's use the formula to find acceleration. Okay, let's use the formula to find acceleration. We can use this formula. You can use this. We have V initial times T plus half dt squared. Okay, so since our free body, let's say in an experiment, we are dropping an object which is at rest, so V initial is going to be 0. So we remain with half dt squared. So making G the subject of the formula here, you can try out. We are going to have 2s over G squared. What does this mean? So to produce the large value of G, we need to have G which is very small, and the S must be large. So the only thing which is going to be true, air resistance. So air resistance, as I said, air resistance is the drag force which is taking the object up. Let's say we are dropping the object as the experiment is telling, it's a free falling, and air resistance is taking it up. So air resistance is going to increase the time. Instead of it falling fast, it is taking it up, making it to take a large time. It's going to take longer than normal falling time. So air resistance is going to increase time. So this is going to be not going to be our right answer, because we need time which is very small. What about the dimensions of the body which are too large? Okay, the dimensions of the body which are too large also. When an object is too big, the air resistance is increased. The air resistance is increased. So increasing the air resistance increases time. And we need to have time which is small. So this is not going to be true. What about the measured distance which is longer than true distance? Okay, at least this is going to be true, because S is for distance, and we need the distance which is large. So we can keep this to be our answer. What about the measured time longer? Actually, we don't want the time which is longer, so this is not going to be true. So the answer is C. Another question is question 14. An insect jumps with an initial speed of 1.0 meter per second, reaching a maximum height, the maximum height which is called h max, over 3.5 times 10 to the power negative 2 meters. Assume the deceleration is uniform. What is the magnitude of the deceleration? As usual, since we have the h max, we need to understand that at the h max here, the v final is 0. Okay, so, and we have to find the magnitude of the deceleration. So we are going to use the formula. Because we are talking about deceleration, meaning the acceleration due to gravity is going to be negative, so we're going to have then 2g8 there. Okay, we can even say A instead of G. We can even use A. Okay, so our V final already is 0. Our V initial is 1 squared minus 2. Acceleration is, we don't know, but the height is 3.5 times 10 to the power negative 2. That means to say this is same as this can go to the other side. You're going to have acceleration, then you 2 times 3.5 times 10 to the power negative 2. Here we've remained with 1. Okay, here we've remained with 1. So we can divide to get to have acceleration. We're going to divide this. We divide this. Say 2 multiplied by 3.5 times 10 to the power negative 2. Where we are going to have our answer to be 14 meter per second square. So the answer is actually C. Question 18. In the absence of air resistance, a stone is thrown from P and follows a parabolic path in which the highest point reached is T. As you can see, this is the highest point. The stone reaches point Q just before landing. the vertical component of the acceleration of the stone is what? Okay, so the vertical component of the acceleration. So what happens, what you need to understand is this, to say that the acceleration from P, since this is the Vmax, it is like the midpoint, okay? So the acceleration from P, the acceleration from at Q is going to be the same as the acceleration at T. So for it to accelerate from ear to ear, also from this point to this point, the acceleration is going to be the same. So this is going to be our answer. So for these questions, you're going to find the solutions in the comment section. So we go to this question. So we have a number of questions, so we need to be fast. So an whole roller moves 1 to 100 tons per hour from a mine to the surface. Convert this rate to pounds per second. We have been given to say that one ton is equal to 2,000 pounds. So we have been given 1,200 tons per hour. We need to convert this. So we say, as usual, we use dimensional analysis to tons, then over hour. To get rid of tons, I've been taught to say that 1 ton, because we want this to cancel, we say 1 ton is equal to 2,000 pounds. Then to get rid of 1 hour, we say 1 hour, we take 1 hour on top so that it may cancel. It's equal to 3,600 seconds. So this and this will cancel, and this will cancel. So I'm going to say 1,200 times 2,000 divided by 3,600. You are going to get something which is going to be 666.6666 like this. Okay, LB per second. And as you can see, this is very close to this one when we round it off. The polar coordinate of a point r and theta. What are the Cartesian coordinates? The Cartesian coordinates are in the form of x, y, where x is given by r cosine theta and y is equal to r sine theta. So we say r is 5.5, cosine 240, where we get our x coordinate is going to be negative 2.75. Then when we say y is equal to r, which is 5.50 sine 240, our r, our y is going to be, once you find this on your calculator, going to get negative 4.76, negative 4.76. So actually the true answer is going to be D. Okay, true answer goes to be D. Because that's where we get. Okay, so we go ahead and do question 5. A car travels 20 kilometers due north. So they're saying that a car travels 20 kilometers due north. That means it's moving like this, because this is the north direction. Then it traveled 20 kilometers. What happened then? 35 kilometers in the direction west of north. Okay, we know that if this is north, then west should be here. This is going to be our west. So now, for it to move, this is our north. Okay, it has moved in the first place for this 20 kilometer, and it has moved west of north. When they say west of north, it means it is between west and north. So this vector is going to go like this. And the distance it has covered is actually 35 kilometer. Okay, but when you say west of north, it means this angle is close to this. So the angle is close to north. This is where we have our 60 degrees. So now you can go ahead and find the magnitude and the direction, because this is our east. Okay, so actually this is our south. All right, so for us to do the need if, we actually going to say we are going to treat this our vector A and this is our vector B. So our vector A is 20 kilometer, the magnitude is 20, and the direction, since it's going due north, when you say due north, it means it's at 90 degrees. Also check out for the video I'm going to share on this, where we talked about how to find the direction and here also the quadrants. Then vector B has a magnitude of 35 degrees, 35 kilometer. Then the direction, as you can see, since we have 60 here, we measure from this side, then go to where the vector is. So we have 90 here, plus this is 60, we get 150. Okay. So we can go ahead and find the x components. The x component will be 20 cos 90, and the y component is going to be 20 sin 90. What about B? We say 35 cos, this is our bx, 35 cos 150, and by is going to be 35 sin 150. Okay, so our ax, when we say 20 cos 90, we actually get a 0. What about bx? 35 cos 150, 35 cos 150, we get 90. 35 cos 150, we get negative 30.31. What about our ay? We say 20 sin 90, we actually get 20. What about our by? We say 35 sin 150, we get 17.5. So now, since we need to find the resultance displacement, this from this point all the way to the start, this is our resultance. Okay, so our resultance, we're going to find the Rx. The Rx is the summation of the two. We had this and this x component, we had them, we get negative 30.31. Then our Ry, we had the two, this and this, these are y components, so we get to have 37.5. So now I don't have any space, so I must use this. So to find the R, the resultance vector is going to be Rx squared plus Ry squared, where we're going to say Rx is, we're going to square this, then also this, then we put under the square root. This is what it means. So our R is going to be 48.2 kilometer. Okay, what about the tangent? What about the theta? We say the theta is equal to tangent inverse over the y component is 37.5 I mean, over the x component, which is actually 30.31. We get to 40 we get to have what do we get to have? We get to have something which is when we say tangent inverse of PT. Take note that I've ignored the negative here. Okay, I will always emphasize to say ignore the negative. We are going to use quadrant to find the right direction. So what we do is that after we say the tangent inverse, we are going to have 59, 50, 51 degrees. Now understand to say that the x component is negative. The x component is negative and the y component is positive. So this is actually in the second quadrant where y is positive and x is negative. And in the x quadrant, I mean the second quadrant, we subtract the angle from 180. So I'm going to say 180 minus 51, and our answer is going to be 29 degrees. So you can look for that answer is actually C. Okay, so now we get question 9. The question reads: a jet lands on a aircraft carrier at this. Since it's landed at this, what is the acceleration assumed constant if it stops 2 seconds due to an arresting cable that snags the airplane and brings it to stop? Okay, so the V initial is 140 miles per hour. We are lucky that they have already been converted this for us, so we say our V initial is going to be 63 meters per second. Then the acceleration, it is stopped in 2 seconds. Our time is actually 2 seconds. Then when they said it brings to stop, it means the final is 0. Okay, so we can find the acceleration using this information. So we can use the formula V initial is equal plus acceleration times time. We use this formula. Okay, so now as usual we can make acceleration the subject of the formula. So we're going to say this is going to the other side. We are going to have our V final minus V initial is equal to acceleration times time. We divide by t, we divide by t. Our acceleration is going to be V final minus V initial over time, where our acceleration is going to be, our V final is 0, our V initial is 63 over time, which is 2. Our answer is going to be actually 31.5 meters per second square. And the answer, which is very close to this, is actually we have a negative here. So we must have a negative here. So the answer is C. Question 4, 2023 test 1. So question 4 leads: if the average velocity, okay, if the average velocity is if the average velocity of an object is 0 in some time intervals, what can you say about the displacement? Okay, first of all, let's understand about the average velocity. It can be written as the average velocity is given by the change in displacement x final minus x initial. Minus x initial over time. Let's say over time. What can you say about the displacement? So for us to have this average velocity to be 0, it means on top we must have 0. Okay, because we don't need to have 0 in front here. I mean in the denominator. So we must have 0 on top for us to have the average velocity, which is going to be 0. So the displacement here, the displacement on top should be 0. Actually, it should be constant. Okay, we must have a constant 0 in other cases, you can find to say that the average velocity is found when the displacement, must take note of this, the displacement is constant. I mentioned also in the videos, of which some of which I've already shared in the watching. In the comment section, you're going to check it out after watching the video. Alright, so this is one of the questions which I found to be very interesting. Okay, so the question is, a ship is traveling with a velocity of 8 km per hour in a direction fate east of north. What are the components of the ship's velocity in the east and north direction? So let me try to draw the XY plane. So we have the north, south, east, and west. So this ship what you need to know is that the ship is traveling in the direction east of north. East over north. It means the angle, since we have east, when you hear east over north, it means the angle is close to north. So the ship is traveling in this direction, and we have fate here. We have fate here. So let's say this is vector A. Okay. So now, how are we going to find what are the components of the ship's velocity in the east and the north direction? So the north direction is the y, and the east direction is the x. So here is where many students made a mistake here, because as you can see, the questions, the all answers are matching. So as I always emphasize, measure an angle from the positive x direction. So we start from here all the way to here. Since this had up to 90 and we have been given 30, that means here we have 60. Okay, so this is the angle we're going to use. So the x component, which is the east, is going to be x is equal to 8 there, then cos 8. I mean cos 60. If you use 30, the answer are going to be the same but opposite, and you're going to fail the question. So when you say 8 cos 30, you're going to have 4 km per hour. Then our y now is going to be 8 sin 60, which is actually going to be 6.9 km per hour. So the answer goes to be B. Actually, the answer is B. I'm using the white color, so I can't point on that. The question is in white background. Okay, so now this question is also the same as the one we've done before. It has been repeated. Okay, so two forces of equal magnitude are represented by two polar vectors. One is directed towards the east, okay, and the other is directed towards the north. Okay, this is the north, and we have been told to say that these are of equal magnitude. So what are we going to, what is the question? What is the direction of the single force that will balance these two forces? Okay, so to balance these two forces, we need to have another force which will what? Which will balance the force in the east direction, and this should go to the what? Should be equal magnitude of as the east, but it should go to the west. And to balance the north, we must have another one which is going to the what? To the south, in the opposite direction to this. So I'm going to say that this force must be towards southeast. I mean southwest. Southwest. This is where our force need to be. So now we go ahead and do some questions which are actually structured questions, which is very important. So, explain how an object which is at rest and one moving with a constant velocity may be considered to be in the same state. Okay, so to understand, let me try to adjust the font here. Okay, explain how the object which is at rest and the other one moving with a constant velocity are considered to be at the same state. Okay, so the first thing which you need to understand, for an object which is at rest, the acceleration is 0. Okay? And the one which is at constant velocity, also the acceleration is going to be 0. Now, since we know that force is equal to mass times acceleration, and both the acceleration is equal to 0, meaning the net force for both objects, the one with constant velocity and the one with which is at rest, is going to be 0. Okay, so to understand how the acceleration at the constant velocity is equal to 0, we know that the acceleration is given by v final minus v initial over time. When they say constant velocity, it means the velocity is not changing. So for example, if we say 5 minus 5, we are going to have 0 over t, which is going to be 0, because the acceleration is not going to, so the initial and the final must be the same. So that means to say, the one which is at rest and the one which is at constant velocity, they have the same net force. So you can say that both acceleration is equal to 0 and the net force is going to be 0. So you can write everything which I've written here and write the statement like this as an explanation. This is how you explain. Okay, so now another question is, a footballer kicks a ball on horizontal ground, giving it an initial velocity of 25 km at an angle to the horizontal. Actually, this is the first case. This is the second case of projectile motion. So, as you can see, we have an angle of 35 here, and this is the initial velocity and the horizontal range here. Let's say we have the maximum height here where it has reached, and at the maximum height already we know that the v final is equal to 0. Here our v initial is actually 25 meters per second. Okay, so where will the ball be 1.2 seconds after it is released? So the first thing, we are going to break this v initial into components, because we know that our v initial has been projected at a certain angle here, and our v initial is actually 25. So we're going to have our v initial y and our v initial x at 35 degrees. So our v initial y is equal to v initial, which is 25, then sine 35, and our v initial x is going to be 25 cosine 35. Where we're going to get, so our v initial y is going to be 20. Our v initial y is going to be 14.35, and our vox is going to be 20.475. Okay, it's actually meters per second. It's also meters per second. So now we have been asked where the ball is going to be. Okay, where the ball is going to be after 1.2 seconds. So we need to understand to say that the projectile motion is the motion in two directions. We have the motion in the y direction and the motion in the x direction. So what happens is that in the x direction, the velocity doesn't change because we don't have acceleration in the x direction here. So this is going to remain to be our x value is going to be 20.475. Okay, what is going to change is the y direction. So in the y direction now we're going to find this is like the height, which is in this case we're going to say y is going to be v initial. Now this v initial will be v initial y because we're dealing in the y direction times t. Since we are going up, we're going to have half negative half dt squared. Okay, so now we can solve for y. Our vy initial is this. We have 14.35 times 1.2 minus half. You have 9.8 multiplied by 1.2 squared, which is time. So our y is going to be actually 10.2 meters. Okay, we're going to have 10.2 meters. This is our y direction. Actually, this is the velocity. So to find the distance at which it's going to be at 1.2 seconds, we are going to say our distance is, we are going to this as the range, which is vox times time, where our distance is going to be at now our vox is 20.475 times time, which is 1.2, where we are going to get our answer to be 24.6 meters. So you can now state to say that it is going to be in the x direction, it's going to be at this, and in the y direction, it's going to be at this point. So now the other question is to calculate the velocity of the ball after 1.2 seconds. Okay, so the velocity of the ball after 1.2 seconds, actually this velocity is the one which is found by finding the vx squared plus vy squared. Okay, actually our vx doesn't change. Like I said, the vx is not going to change. It will remain to be 20.475. Okay, the change is going to be detected on the vy. Okay, we are going to use this formula to find the vy. These are the formula I showed you. To find the vy, you say voy minus dt. Okay, so what you do, you say vy is equal to voy. We already have this one, 14.35. So 13 is it 14.35 minus 9.8 times 1.2. So our vy goes to be 2.59. Okay, 2.59 meters per second. We also have meters per second here. So we can go ahead and find the speed, which is actually v is equal to, since we have vx squared is the same as we have 20.475 squared plus 2.59 squared. Our v is going to be actually our v is going to be 20.64 meters per second. If we want, we can find the angle so that at least we have the answer, which is complete tangent inverse over the y coordinate 2.59 over 20.475. we are going to have the angle of 7.21 degrees. So the other question is, where will the ball land? Okay, where the ball is going to land. Actually, this is the second case. The ball where it's going to land, they're asking about the range. and the length is given by Vx multiplied by time. Okay, our Vx already, we have our Vx is V initial cosine theta, and our time, okay, the time here, the time from this point to this point is given by V sine theta over d. So now the time now from this all the way to this point is going to be multiplied by 2. I showed this. So I'm going to multiply by 2 V initial sine theta over d, which we actually simplified to the length, because when we multiply this V initial, we are going to have V initial squared, then 2 sine theta cosine theta over d. In fact, I've even made to the point of showing you how we used to derive the formulas. So 2 sine theta then cosine theta is a double identity for sine 2 theta over g. Depressing the given values, because the initial velocity is 25 squared, then sine 2 theta, meaning 2 times theta, which is 35, over 9.8. Okay, is our angle 35? Let me check. Yes, our angle is actually 35, so our range is going to be, our length is going to be 60.07 meters. So the other question G, a track covers, so the distance is 40 meters, and in the time, which is 8.50 seconds, while uniformly slowing down to a final velocity. The final velocity is actually 2.80 meter per second. Then we are asked to find the original velocity, which is the initial velocity, which we don't know. So we are going to use the formula, a very simple formula which you need to know. As this, we are going to use the formula, which is V initial plus V final times time over G. Okay, so now we can make V initial the subject of the formula. So we are going to say we multiply this times this. We are going to have our, this will remain because we have this times this. We are going to have V initial plus V final times time. We are going to have x times g. So to get rid of t, we say we are going to divide t everywhere. We're going to have V initial plus V final is equal to distance times g over t. Now we want to remain with this, so we take the V final to the other side. So now we can replace the given values. The distance is 40, then that is 9.8 minus 2.80, where here we have our time of 8.5. So our V initial goes to be, our V initial is going to be 6.61 meters per second. Check out for this video in the in the description section, and make sure you answer this question. It's very important. Okay, a package is dropped from a helicopter that is descending steadily at a speed. So we have the speed after t seconds as elapsed. What's the velocity of the package in terms of V initial g, and it actually the formula they are talking about is v is equal to v initial plus dt. Okay, now what you need to understand is that since this was descending, the acceleration is going to be negative. Okay, the acceleration is going to be negative, so our d is going to be negative. Even our v initial is going to be negative because this was descending towards as the packet is dropped, it means moving downwards. So the velocity, because we know the velocity is a vector quantity, is going to be negative. So we are going to have v is equal to negative v initial minus dt. So we can factor out negative. We're going to have v initial plus dt. So this is going to be our answer. Another question, a rescue helicopter wants to drop a package of supplies to isolated mountain climbers on a rock ridge 20 meters below. Okay, if the helicopter is traveling horizontally with a speed of 7 meters per second and someone in the helicopter throws the package in the horizontal distance of 400 meters in advance of the mountain climbers, with what speed should the package be given so that it arrives precisely at the climber's position? So, as a matter of fact, what you need to understand is that if the helicopter, we know that the helicopter wants to drop something which is from the height of 200 meters below. That means from here, we have 200 here. Okay, 200 meters below the ground. Okay, this is where the helicopter is, and I've been told to say that the horizontal distance is 400. Horizontal distance is 400. So as this drops, okay, and the Vx, the distance in the x direction there is actually 70 meters per second. And we has to find with what speed should the packet be given so that it arrives precisely at the climber's position. So, as usual, what we need to achieve, we need to achieve the formula of Vx squared plus Vy squared. So as usual, our Vx, okay, we need to, actually Vx is going to be found by, we have the length, okay, the length is given by, okay, we say the length is given by V or x times t. Okay, v or x times t, we need to understand that. Alright, so where the range already we have 400, and the v or x is what we are actually looking for. Okay, the v or x is what we are actually looking for. Now, this is the first case, as you can see. For you who watch the video, this is the first case. Okay, and the time for the first case is given by 2h over g. So here we can say multiplied by 2h over g. We get to have 400 is equal to v or x multiplied by I8 is 200, then 9.8. Okay, so solving for x is like we are dividing this into this. So our Vx, our Vx is going to be 62.63 meters per second. But what we need to understand is that, as you can see, the Vy we don't have motion in the y direction. As you can see, it was moving in the x direction. We don't have motion in the y direction, so the Vy is 0. So replacing that in the formula, we're going to have the Vx 62.63 squared plus 0. So squaring this is same as, because the square and this will cancel, will still remain with 62.63 meters per second. As simple as that. This question you also check it out in the comment section. It's a very important question. It came 2024 exam. Make sure you know these 4 questions. Same applies to this question. Okay, so as for me, I'm going to handle this question. So a model rocket is launched straight upwards with an initial speed of 50 meters per second. It accelerates with a constant upward acceleration of 2 meters per second square until its engine stops at an altitude of 150 meters. What is the total distance covered by the rocket from the time it is launched up to the time it landed? Actually, this is one of our important questions. Okay, what you need to know. So, let's say this is our let's say this is our rocket, and it has been launched. Okay, it has been launched at an initial speed of this. So we say the V initial is equal to 50 meters per second. So as it was launched, it accelerates with a constant upward acceleration of this until its engine stopped at an altitude of this. So the engine stopped somewhere. So let's say the engine stopped here. Okay, and I've been told to say that the distance at which this stops was actually 150 from where it was launched. Now, when this is stopped, okay, what you need to understand is that this has to accelerate itself. Okay, now the engine just stopped, but the rocket will still moving up until it falls down. Okay, so now this is the ground. All right, so what is the total distance covered by the rocket from the time it is launched up to the time it lands? So what we need to understand, that from this point to this point it is 150. So we need to find this distance, this height. We need to if we be able to find this height, then everything is going to be very simple for us. Okay, so now the first thing here, is that what we need to understand, the V initial is this. Okay, the V initial is this. Now understand that we need to find the velocity when the engine stops. Okay, we need to find the velocity when the engine stopped at this point. This is the velocity we need to find. Already we have the following information. From here we have the distance, which is the height, which is actually 150 here, 150 meters. We also have what else do we have? We have the acceleration, because it accelerated at a constant acceleration of 2 meters per second square. So with this information we can find the velocity here, the final velocity here. So we are going to say, we are going to use this formula, V initial squared plus 2as. Okay, 2as. So to find this velocity, say the square root of V initial squared plus 2AS. So we get to have our V initial is actually 50 squared plus 2 times acceleration, which is 2, and the distance over 150. So the speed goes to be 55.68 meters per second. Since we have now the speed here to be 58.6, actually 55.68. Let's now find the height it rises after the engine has stopped. So it's this height from this point all the way to this point. Okay, this is the height now we want to find. So now, from this point, you are going to treat now this to be our V initial. Okay, this is now going to be our V initial, because this is where now our motion starts. Now, at this is the H max. This is the highest. This is the maximum height. And what to do, about the maximum height, the V initial, the V final is always 0. Okay? So now, as this now moves up, it is now under the influence of gravity. And since it is going up, the acceleration due to gravity is going to be negative. With this information, we can find the height using the same formula here. So in this case, the height is this. So our V final is 0. Our V initial is now 55.68 squared plus, now because of the negative here, we're going to have negative 9.8 multiplied by h, which we don't know. So that means to say this is going to go to the other side. It's going to be positive. We're going to have 9.88 is equal to 55.68 squared. So we can divide now. We divide 9.8 everywhere. We're going to have here h is equal to 55.68 squared over 9.8. So our height is actually going to be, our height is this small height here. The height it rises is going to be 158 in respect to the number of significant figures, 158 meters. Now understand this. We want to know the total distance. So from this point all the way to the maximum point is going to be the H max. So the H max is going to be 150 this plus 158. Which is going to give us 308. What you need to understand that the distance from this point to this point is same as the distance from this point all the way to this point, as is actually CBA. So to find the total distance, since we have the distance from A to B, even this is the same distance which is also from B to C, so it's like 308 times 2. So the total distance is going to be 2 times 308, which you are going to have 616 meters. Another question which is very important also, the projectile is launched at the head of the cliff. It is at the head of the cliff, 115 meters above the ground. What does this mean? Meaning the projectile, let's say we have the projectile here, and here under the earth, below the ground, we have 115. The height is 115 meters. It is 115 meters. Okay. It is 115 meters, and this is projected. It is projected above the ground. It is projected above the ground at an angle. That means it is projected. It's moving like this until it falls. Don't mind my drawing. My pen has just skipped. Okay. Calculate the velocity of the projectile when it is at 15 meters height above the ground. Okay, let me redraw it because the statement is now different. Okay. What we have this. Let's say now we have a distance which has remained. It was here. Then we have a 15 meters. This is what it means to say that it is 15 meters above the ground. This is why the projectile reached. It didn't hit the ground, so it was 15 meters above the ground. So for us to find the velocity, actually this velocity, as usual, is the one we are finding to be our Vx squared plus Vy squared. Okay, so we know that this is projected at the certain angle, which is 40 degrees, and the V initial is actually 60 meters per second. So to find the Vx, first we can break this into components. We are going to say we're going to have Vy, Vox, which is going to be our V initial cosine theta, which is going to be 60 cos 40, and the answer of 6 cos 40 are going to have 38. We're going to have 45.96 meters per second. We also have our Voy, which is our V initial sine theta. We're going to have 60 sine 40. We get our answer to be 38.57 meters per second. Okay, meters per second. Then what's next? The next thing is so now we need to find Vx and Vy. These are just components, you shouldn't confuse them. Okay, but what you need to understand is that Vx is not going to change. Okay, Vx will remain the same because the velocity doesn't change in the x direction because we don't have acceleration in the x direction. So Vx is going to be the same as V. The x component of velocity of the initial velocity is going to be 45.96 meters per second. Okay. Now to find the Vy. Here to find the Vy, we use the same formula. Okay. We're using the same formula which we actually using. Now, since it's Vy, we say Voy minus Voy minus 2gh. Okay, it's a 2gh. Now, I want you to understand this. So from here now, you can tell to say our Vy is going to be the square root because I want to get rid of this. Voy is this 38.57 squared minus 2 times 9.8. Now what about the height? The height is the trick part. The initial is 115 because it started at 115, ending at 15 here. So that means the final is 15. So we say 15 minus 115. We are going to have 100, negative 100 meters. So that means we are going to say negative 100 meters is the height, negative 100 meters the height. So our Vy is going to be, since yes, we say positive or minus, okay, it's going to be positive or minus negative, once you punch this now on your calculator, you're going to have positive or minus 58.72 meters per second. But the most important thing you need to know that as this was falling, the velocity, the Vy is going to be negative because it is going down. So we will choose the negative one. So we go with the negative one. Okay. So since we have this, we also have this. You can press them in this formula and find the value of V. And the most important thing, you can also find the angle. The angle of projection, tangent inverse over Vy over Vx. Already you have the following, and you follow the rules of quadrants. Another interesting question is the river has a steady speed of, so the speed of the river is 0.5 meter per second, and a student swims upstream a distance of the distance of 1 kilometer, which we can directly convert to meters to be 1,000 meters. So the student meets a distance, they say distance of 1,000 meters, and swims back to the starting point. So he went upstream and downstream. That means if let's say the river is, to understand very well, say the river is flowing this direction. It's flowing this direction. So the speed of the river, which is actually 0.5. Okay. So now the student can swim at this speed. The speed of a student is 1.20 meters per second. So the question is, if the student can swim at this speed, how long does the trip take? What you need to understand is that the student first went upstream and swims back. So he went upstream and downstream. So since the river, we know that the river is traveling this, is flowing this, okay, is flowing this direction, and is flowing at 0.5. Okay, so now the student, when the student swims up at 1.2, we are going to have vectors which are in opposite directions. So the resultance vector for these two is going to be, we are going to say the V of a student when it travels upstream is going to be, now we subtract the 2, 0.5 minus 1.2, we are going to have 0.7 meters per second. Okay, so now from this you can find the time. Okay, you can find the time because we know that velocity is equal to distance over time. So to make time the subject of the formula, we are going to multiply this time. This we are going to have V times time is equal to G divided by V everywhere. I'm going to G over G over V. So our distance already is 1,000. Our velocity is now 0.7. So our time in this case is going to be, our time is going to be 1,400, 28.6 seconds. I think I don't have a space here. Okay, so now the other question now, what is the time it took as he was going down? Okay, we know already the lever is flowing in this direction as we already know, and you also go down at the same speed of 1.2. That means these now are facing in the same direction. So the velocity as it was flowing down is going to be the summation of the two forces of the two vectors, which are going to have 1.7 meters per second. So from this we can find the time to say distance, the same formula, distance over velocity, which is the distance is 1000 as we found in the first place, over 1.7. So the time goes to be actually 588.2 seconds. So the total time now, the total time of the trip, because this is when the students swim upward and this one downward. So we had the total time is going to be the summation of the two, where our answer is actually going to be 2016.80 seconds, where we can even convert this to meters, because the number is too much. We divide by 60, we get our, in meters, our answer to be 33.61 minutes. In fact, minutes, not meters. So now this is also another question. As you can see, we have this question. We have already solved this. So what we are from doing. So this is not within the coverage. It is on forces. So we're going to do this question. Okay. So to start a avalanche on a mountain slope, an artillery shell is fired with an initial velocity of this at an angle above the horizon. It explodes on the mountain 42 seconds after firing. What are x and y coordinates of the shell where it explodes relative to the firing points? As usual, we have this thing fired like this. Okay, we don't know where it landed. In this case, we are not being told where it landed. We have the range. Okay, what we have just been told is the angle of projection is 55 degrees, and the V initial have been given to be 300 meters per second. What I also have been told, to say the time where it explodes. It explodes 42.0 seconds. Okay, so the question is, what are the x and y coordinates of the shell where it explodes? Okay, as usual, for us to find the x and y coordinates, first let's break down this into components. Let's break down the v initial into components. We're going to have the v initial x is going to be v initial cosine theta, which in our case is going to be, our v initial is 300 cos 55, we get 172.08 meters per second. Then our v or y is going to be v initial sine theta, which is going to be 300 sine 55 is going to be 245.76 meters per second. Okay, so now we need to find where it explodes, in the x, in the y direction, and in the x direction. So the x direction actually is found by v initial x times time, where our v initial x is actually this 172.08 times time, which is 42 seconds. So our answer goes to be 7,227.76 0.4 seconds. Okay, 0.4, not seconds but meters, because we're actually talking about the distance there. So what about the space here? What about the the y direction? What about in the y direction? Where did it explode? Okay, so it exploded. We use the formula since we already have as usual, the formula is one and the same which we are using. We've been using this formula for the y direction. We use v or yt plus since we have time. Since we have time, we go for this formula. We can't use this. And the reason is simple, because we haven't been given the distance. Okay, we have been given time, so we go for the one which we have time. So we have the height to be v initial, y is actually this value, where is this value 245.76 times t, which is 42. Now since it is going up, okay, it is going up, this is going to be negative, this is going to be negative, affecting the positive here, the 9.8 and 42 squared. So the height goes to be 116.78.32 meters. So you can even now tell to say that it was at, in the x direction, it was at 7,227.4 meters. Then in the y direction, it was at this is like a coordinate where the projectile was. So this is at 1,678.32 meters. This is where the projectile now was. So I think this marks the end of our today's session, which is the preparation. So as you can see, this question is also going to be shared in the link. Okay, so this is my main emphasis. Okay, this is where preparation comes. You've watched the video for the questions which I didn't answer for you, which I've just answered for you today. But make sure you answer all tutorial sheet from tutorial sheet 1 to tutorial sheet 4. For you guys, this is going to be a revision because I've shared all the tutorial sheets. You just revise from all the tutorial sheets. Okay, then in the cell physics or quality physics, go and answer examples. Those solved examples, solve them. Examples from cell quality physics and the lecture slide which have been given, solve all examples from that. The other thing is that in cell physics, there are things which are going to see in red, quick quizzes. In cell physics, there are quick quizzes. Make sure you answer them because they are going to be part of the MCQ questions. Okay? The other thing, you have written now quiz 1. Okay? You have written quiz 1. Make sure you go through the quiz questions which you answered, which you were given, because you haven't shared the quizzes. I would have also included in the question. Make sure, because some questions are going to be repeated from quiz. Okay, so the videos which I'm going to share in the link, make sure you at least some. Okay, but my main emphasis is that you watch all the videos. So for you, if it's your first time to the channel, consider subscribing. Subscribe to the channel. You like the video. Also share so that it may reach to urgent. You can also hit the notification button. I actually don't know how to write a notification button. It looks like this, so that you may be updated about new uploaded videos. So thank you for watching. See you in the next video.